Okay, today we're going to go over 5.4, system of linear equations in two variables. We're going to learn how to determine if an ordered pair is a solution of a linear system, and we're going to learn how to solve systems of equations by graphing, substitution, and elimination. Okay, systems of equations. Two equations in the form of ax plus by equals c are called a system of linear equations or a linear system. A solution to a system of linear equations in two variables is an ordered pair. So, first, let's figure out how to determine whether an ordered pair is a solution of a system. The way we're going to do that is, here come our instructions. Please write these down. Insert the ordered pair into each equation and see if a true answer results. If it does, then the ordered pair is a solution. Okay, so in this case, x is 1, y is 2. We're going to substitute them into the first equation. 2 times 1 minus 3 times 2, we want to know if that equals -4. So let's do some multiplying. We get 2 minus 6 equals -4. Is that a true statement? Yes, yes it is. Now we're going to substitute x for 1 and 2 in for y in the second equation. We get 2 times 1 plus 2. Is that equal to 4? Is 2 plus 2 equal to 4? Yes. Yes, it is. So, yes, 1, 2, the ordered pair, is a solution to this system of equations. Moving on, let's do another one. Now, let's determine whether 1, 2 is a solution to this system of equations. We're going to do the same thing. We're going to substitute the 1 for x and the 2 for y in the first equation to start. We get 1 plus 2 times 2. Is that equal to 2? Well, 1 plus 4, does that equal 2? No, no it doesn't. So no, this is not a solution to the system. We don't have to try the second one because we already know it doesn't work for the first equation. So no, 1, 2 is not a solution. Okay, so that's how we determine whether an ordered pair is a solution. Now we're going to solve a linear system by graphing. To do that, we want to get these into y equals mx plus b, or slope-intercept form. So let's algebraically manipulate this first equation. 2x plus 3y equals 6. First thing we have to do is subtract the 2x and then divide by 3. And we get y equals -2/3 x plus 2. Then let's get this equation also into slope-intercept form. So again, we want to subtract the 2x, and that's all we had to do. Now, remember, to graph, we want to start over here. That number is where we start on the y line. So on this graph, we start at 2. And then our slope is over here by the x, and that's -2/3, which means we go down 2 and to the right 3. And then we connect everything with a line. Let's do the next line. We start here on the -2 on the y line. Then our slope is -2, which is the same as -2/1, which means we go down 2 and to the right 1. And then down 2 and to the right 1. Or we can go up 2 and backwards 1. And connect it all with a straight line. Now, where the points or the lines intersect, that point right there is the answer to our solution. So that is the ordered pair -3, 4. That is our solution. If we put that ordered pair in here, into both of these equations, just like we just did, you'll find that you get a true statement for both of them. So that's how we solve by graphing. To solve a linear system by the substitution method, you solve either of the equations for one variable in terms of the other. It doesn't matter which variable. If one of the equations is already in this form, you can skip this step. Step 2. Substitute the expression found in step 1 into the other equation. This will result in an equation with one variable. So one equation, one variable. Solve that equation, then put that value back into one of the equations in step 1 and find the missing variable. And then you should check to make sure that you got the right answer. Let's do an example. Okay, so this is how I like to explain this. I hate strawberries. I think they're disgusting. It's not a popular opinion, but I won't eat a strawberry. So I would rather just take a vitamin C pill because a strawberry is high in vitamin C. So in this case, we have a Y all by itself. There's my strawberry that I don't want to eat. Cannot stand them. This right here is the vitamin C pill. So during the course of my day's nutrients, I am not going to eat that strawberry. Gross. Throw it away. Instead, I'm going to substitute in my vitamin C pill and go about my day. So, we take out the Y, we put in what it equals. And then we go about our day. We just put that right in there. That negative x minus 1 goes where the Y is. We took out the strawberry, put in a vitamin C pill. Then we just have to distribute. So negative 3 times negative x is plus 3x. Negative 3 times negative 1 is plus 3. Combine our like terms. Subtract the 3. And then divide by 7. We end up with x equals 3. Whew! We're halfway done. Now we want to take this x equals 3, stick it in one of these equations. I pick this one because it's the one I pick. There's no rhyme or reason to it. Then you're going to take that equation, y equals negative x minus 1, and we'll get y equals negative 3 minus 1, and we get y equals negative 4. There's the second half of our equation. So our answer is 3, negative 4. Once again, the answer is an ordered pair in alphabetical order. So x comes first, then y. If you had different letters, you could substitute those in. All right, now let's solve by the substitution method on this one. This one, our y is already by itself. So there's our vitamin C and our strawberry. Take that strawberry, get it out of there. Gross. And we're just going to stick in our vitamin C pill. And so we have 5x minus 2. There's our vitamin C. And we just do the algebra. And we get x equals 6. So now we take that x equals 6. And we stick it back into one of the equations. We get y equals 3 times 6 minus 7, which is 11. There's our second letter, and our ordered pair is 6, 11. Okay, so here we have another example of substitution. This time, our strawberry is not all by itself. It's got this additional stuff, but we can do this. So to get the strawberry by itself, we add the 2y to both sides, and now we have a strawberry, we have a vitamin C pill, or we have an x, and it is, because equal means is, x is 2y minus 3. So we're going to take out this x up here and put in the 2, make that go away, because strawberries. And then we're going to put in our 2y minus 3. And then we rewrite and solve for y. This is the part where you're going to want to be careful when doing this that you don't lose any negatives. Okay, I'll give you a little hot minute there to write all that down. Take a look at it. Might want to pause the video. Okay, so y is 4. So we're halfway done. We're going to plug this in to that equation because I feel like using that one. I think that one is easier. And we come up with x equals 5. Once again, you might want to pause the video to be able to write all that down or just examine it. See if I did my algebra correctly. I think I did. And 5, 4 is your answer, x before y. All right, one more. So this one, you can see that none of our x's and y's are by themselves. So this is going to be involving some division. It doesn't look like any of, nothing is divisible by 4 in this row. Nothing is divisible by 2. Nothing is divisible by 3. And nothing is divisible by 5. So I happen to think halves are the easiest fractions. So we're going to go with halves. There's our strawberry. So we're going to divide everything. Well, first we're going to add the 3y. So we get 2x equals 3y plus 7. We're going to divide everything by 2. Yeah, okay, this is yucky. Not even going to lie. There's our strawberry. There's our vitamin C pill. If you are comfortable using fractions, yeehaw, let's go for it. Take out the strawberry, put in the vitamin C pill, and we end up with that loveliness. In this case, it didn't turn out to be so ugly because we're multiplying by 4 and 2 is our denominator. We get a y equals -1. We substitute that y back in. Here we are over here, solving for x, and we get x equals 2. So our answer is 2, -1. Now for the good news. We are not going to have messy, horrible, ugly problems like this. Partially because I'm not asking you to show your work. And there is an easier way to do these types of problems. Unless you like fractions and you've skipped a lot of school so you don't know how to do it any other way. It's totally doable. This is how I got through systems of equations in high school. But you don't have to. You can do solving linear systems by addition, which is elimination. So first thing you want to do is make sure they're ax plus by equals c. So xy equals sine of c. And then either add them together and let one drop out, multiply one or the other equation by something, multiply both equations by different numbers, then add them together. One of your variables should drop out. Let's look. So here we go. I'm going to rewrite these down here. Okay. Now, if we were to add these two equations together, we'd get 11x. No, we wouldn't. We'd get 12x plus minus 6y equals 24. So it wouldn't do us any good to add the two equations together as they are right now. What we want is for the coefficients to be opposites. These have opposite signs, but not the same coefficient. So, can we multiply 2 by something to equal 8? Because the signs are already opposite, we just are concerned with the numbers. So we can multiply this top equation by 4. If we do that, we get 12x plus 8y equals 192 Don't worry about the big numbers. It's not going to be a problem. The second equation, we're going to take exactly like it was. 9x minus 8y equals negative 24. Now, we add the two equations together. And you'll notice pretty quickly that we have opposite coefficients here. We have positive 8y and negative 8y. So those two cancel out. And we are left with 21x equals 168. We divide by 21, and we get x equals 8. We're halfway done. Now we stick that 8 back into one of our original equations. I picked the top one. Doesn't matter which one you use. And then we're just going to solve. We're already pretty good at solving a multi-step equation. There is our second variable. So we have x is 8, y is 12. So we have the ordered pair 8, 12. And the answer is still an ordered pair. We could turn these into y equals mx plus b and graph them. We could deal with some crazy fractions and use substitution like we did in the previous example. Or we could do elimination. Either way, we'll get all the same answers. 8, 12. Okay, and let's look at another one. This one is not x, y equals. In fact, the top one is x equals number y, and the bottom one is y equals number x. So let's get these organized before we start doing anything. So we first have to get the equations to be ax plus by equals c. So let's take that first equation. We want to add 2y to both sides so that we can have xy equals number. So we get 7x plus 2y equals 5. Now let's take that second equation, and again we're going to add the 2x to both sides, and we get 2x plus 3y equals 16. Now, if we added these together, nothing would drop out. We'd get 9x's, 5y's, and 21. So we're going to have to multiply, and this time we do not have opposite signs. So let's look at the y's because the y's are smaller. We can times the top one by -3 and the bottom one by 2 because they're both prime numbers, so we just multiply by the other. And I chose to make the top negative. You could make the bottom negative instead. It doesn't matter. But we're going to multiply those out. Just distributing all the way across. Make sure you get the other side of the equal sign. And then look at our y's. These are how we picked our -3 and 2. They're both 6's with opposite signs. So perfect. So we put our plus, draw our line, our y's cross out this time, and we add together. We get -17x equals 17, so x is -1. We're halfway done. We're going to stick this x back in. I guess I picked the bottom one. So there we go. Once again, it's a multi-step equation, and we solve it, and we get 6. There's our y. So our final answer is the ordered pair xy, -1, 6. There can be one solution, no solutions, or infinitely many solutions to a system of two linear equations. You cannot cross more than once. Like you can't cross twice. Two straight lines can't cross twice. It's either they're just crossing, they're on their way, they're parallel, so they never cross, or one line is just laying on top of the other line. Okay? So, how do we know? Well, if both variables are eliminated when solving a system of linear equations by substitution or addition, one of the following is true. There is no solution if the resulting statement is false. There are infinitely many solutions if the resulting statement is true. So let's try some. Okay. So we have 4x plus 6y equals 12 and 6x plus 9y equals 12. Well, we can't just add these two together, but this is 2 times 2, and this is 2 times 3. So let's times the top one by 3 and the bottom one by -2, because remember we need opposite signs. So then we get 12 and -12. Well, we have to multiply all the way across. So we get 3 times 4 is 12, 3 times 6 is 18, 3 times 12 is 36, -2 times 6 is -12, -2 times 9 is -18, -2 times 12 is -24. Now, we can add these two together. Oh, our x's crossed out just like we wanted them to, but our y's also cancel out. So we get 0 equals 12. Does 0 equal 12? No. No solutions. If you come up with something that is not true, the answer is no solutions. All right, now let's look at this one. Oh, we have to move some things around because y equals 3x minus 2 is not going to happen for us. So we need to subtract that 3x from both sides. We get -3x plus y equals -2. And then we just rewrite that bottom equation like we had. 15x minus 5y equals 10. Now let's look at the x's. We know that 3 times 5 is 15. It's already got the minus. So let's times that top row by 5. We get -15x plus 5y equals -10. On the bottom, we get 15x minus 5y equals 10, because that's just what we had before. Now, let's add them together. Our x's cancel out just like we expected. Oh, so do our y's. Oh, so do our numbers. And we end up with 0 equals 0. Does 0 equal 0? Why, yes. Yes, it does. And so we have infinitely many solutions. I know you have 2 extra pages on your notes. Cross those out. We aren't going to deal with those. Stay safe. Have a great day.